Okay guys, what we're going to do today is we're just going to have a very good knowledge about switching. We're going to try to understand encapsulation and also understand how a switch sends a frame from one VLAN to another. And we are going also to verify how routers work when sending packets from one VLAN to another. In this topology, what we have is we have two routers. Where it's like we have a point-to-point connection from one site to another. Basically, we're going to start from the beginning. The first thing we're going to see is the configuration of the computers. You know that computers are known as layer 3 devices. So let's see if we have configured the basic things that we need to do on the devices of the computers: IP address, subnet mask, and default gateway. In this situation, we have already configured this. We have the IP address in an address or in a network that is 10. The subnet mask is /24, and default gateway is going to be the first one from this group of address. What we're doing is that we're going to have this switch port. It's going to be in VLAN 10, and this switch port is going to be VLAN 10, and this switch port is going to be VLAN 20, and this in VLAN 20. And we're going to ensure that we have connection from this VLAN to this VLAN. At the moment, I have not configured the switch as a I have not made any change on the switch. That means that, that means that the switch will only have everything in the default VLAN, which is the native VLAN as well. And that's the reason why we can have connection from this PC to this PC, and from this PC to this PC. Everything is right now under the native VLAN. We cannot have connection from this PC to this PC. We know why, right? It has failed. We cannot have connection right now because the subnet mask is indicating this PC that the IP address is not in the same range. So we can be sure that there's no connection from this range to another range. So this is basically what I wanted you to know. Right now we're going to configure the switch. This access switch is going to be configured as the interface fast Ethernet 02. We access to the interface, and we put a switch for mode access. With this command, what we do is that we ensure that it will never be a trunk command, a trunk port, and we do a switch access VLAN 20. It immediately creates the VLAN. If you see, right now we have the VLAN there. Exit. Now we go to the interface fast Ethernet 04. Switch per mode access, switch per access VLAN 10. It creates the VLAN 10. Now let's go to this switch. Let's do a show VLAN. Do show VLAN. Okay, there we have 5 VLANs. The default VLAN which is VLAN 1, and the same time is the native VLAN, and 1002, 1003, and 1004, and 1005. These are another default VLANs that are used to transport traffic that it contains traffic from the different protocols, token ring, FDDI. So this is another thing that you need to know. Okay, these are some VLANs that are used, are like for default in these switches. Okay, so now we go to interface, fast Ethernet 0/4, switch per mode access, switch per access VLAN 10. Now in internet fast 01, switch per mode access, switch per access VLAN 20. Okay, the moment we have already created the VLANs, and I have a question for you. Do you know, guys, where you can see or where is stored the VLAN information? Like it is stored in the show running, or is it stored in the NVRAM, or where we can see that stored? Okay, normally we have that stored. Let's see a show run. We don't see that stored in the show running. Okay, what happens is that this information will be stored in the flash memory. We can see that here. There's a VLAN database, VLAN.database. That means that this is a non-volatile memory, and we can have this information saved in case we clear the show running, in case we lost the configuration. Okay, you can know that. Okay, so at the moment the behavior it will be the same. This should work, right? Let's try. Okay, it is in progress. It failed. So do you know why it failed? Let me explain to you. We have already assured that these switch ports are going to be in access mode. These are going to be in access mode too. There's a protocol that's called DTP, Dynamic Trunking Protocol. DTP is a protocol that will be used to ensure that we have a dynamic negotiation of the state of the interface. Let's see right now, for example, the status of the interface FAS03, which is the interface that is facing the switch that is at the left side. Show interface F03 switch port. Okay, if we see, we have the interface in the operational mode, static access, negotiation of trunking on. Right now, it is not possible that I have a frame transported in this interface, because when an interface is in static access, that means that we need to ensure that it's going to be just one VLAN that is going to be sent in that interface. Okay, so let me show you what we can do. Okay, let's do a show. Okay, we have that in dynamic outer. I can make that this interface FA03 will be the one that will be always requiring to form trunking. So I'm going to put that in dynamic desirable. Switch port mode, dynamic desirable. Okay, now we have the trunk. Let's wait until spanning tree does its job. If you see that the link is blinking, that means that we are negotiating also spanning tree. Okay, now let's try if we have connection from this PC to this PC. Now it's successful. As I told you, we need to ensure that we have a trunk connection in these switches. Now let's continue. Now what we are going to need is that we have connection from this VLAN from VLAN 20 to VLAN 10. Right now we don't have connection. Basically because right now they are in two different broadcast domains, are virtual broadcast domains. So to do that, I will need either two options. I will need to create SVIs. I can do that in a multi-layer switch, or I will need to do routing on stick. In this occasion, we're going to do router on stick. And to do that, firstly, we will need to see the VLANs in these switches. Okay, so let's do that. Now there's another rule that we need to do. As I told you, we need to ensure that we have these interfaces in trunk, because we're going to allow all the VLANs so they can be sent in this same interface. Okay, so to do that, we're going to we can do the negotiation with the DTP modes, or we can just put switch port mode trunk. Sorry, let's go to the interface fast 02. Okay, now it's in trunk, and let's do that in this other interface. Okay, now spanning tree is negotiating, as I told you, the blocking of the port, whether it's going to be blocked, and now I have to do that in these same switches, okay, that are facing the multi-layer switch. Since the default status or the default mode of DTP is dynamic auto, if I put the dynamic auto and the switch port mode trunk, the trunk will be formed. You can see here what are the list of possibilities that we have in case we have different modes of DTP. Okay, so let's do a DTP table. Let's go to search for that. Okay, as I told you, this is the table. It's going to be very useful for you to study. What I was doing is I was taking the auto status and then doing a trunk, switch port mode trunk, and what it will be formed a trunk. So let's continue. Okay, Now what we are going to do is I'm going to enter to the router. In the router, we are going to set this interface that is the interface gigabit 00, and I'm going to turn it on, and basically I'm going to virtually create two sub interfaces. The concept of sub interface is very good for you to learn. The sub interface is just a virtual interface that I create to manage two different VLANs. So the router can be like can create in its memory two different interfaces that are just going to be logical, and that it's going to be used for the router to be to have this as directly connected interfaces. So in case we have a packet and the router receives a packet that it says it's going to be sent to a VLAN 10 destination, it will take a look to the routing table and it will see that it's directly connected to the sub interface. And that's basically what the router will do. So let me go ahead and create this sub interface. It's going to be interface gig 0.1. Okay, now first we need to ensure what type of encapsulation we can do. There are actually two different types of encapsulation. .1q, which is the standard, and ISL. ISL is the Cisco proprietary protocol. Okay, you have encapsulation .1q. Now we have to put what's the VLAN ID. Let's put the VLAN ID for the VLAN ID 10 for sub interface 0.1. Now I have to put the IP address. The IP address that this will be is going to be the default gateway. Okay, so okay, and we need to do that in the other sub interface. Okay, that message is saying what I told you. We need firstly to configure what's going to be the type of encapsulation, if it's going to be a .1q or it's going to be ISL. So let me show you, okay? Second. Put that tag, then IP address. Okay, now this should work. Okay, let's try to see if it's going to work. So let me show you. VLAN 10 to VLAN. Okay, so basically what I needed to do is just put in this interface as switchboard trunk encapsulation .1q and then switchboard mode trunk. This is just to let the switch know what type of encapsulation will be, and this one to change the switch port from the static mode to the trunk mode. So let's do a show interface fast03 switch port. Now we have operational mode trunk. Let's go to the previous one, and it used to be static access. Fast forward. We should have connection from one VLAN to another. Let's try another. Successful. Successful. Okay. Okay, now let's do a little simulation just for you to see what happens when we put a frame from one VLAN to another VLAN. What does this switch do? This switch, and this router. Okay, so let's put the simulation mode. It filters. To show all known. It filters. Let's put just the ICMP. Okay. So I told you the .1q header. The frame source MAC address was found in the MAC table of switch. This is a unicast frame. Switch looks in its MAC table for the destination MAC. The frame destination MAC address is not in the MAC table. The switch floats the frame to all ports, the same VLAN except the receiving port. So basically the switch in the middles are going to do the float because they will see its MAC address table and they will see that they don't have the MAC address of the sub interface. So they are going to continually float and until it reaches the router. When it reaches the router, we'll see the sub interface as accept frame from this VLAN. The frame's destination MAC address matches the receiving port's MAC address, the broadcast address or multicast address. So basically the sub interface gigabit 002, okay, 1 second, accepts frames from this VLAN. How? Because it will be tagged in this .1q header. The frame's destination MAC address matches the receiving port's MAC address, so it will be accept. The device de-encapsulates the PDU from an IEEE 802.1q frame. Now it will see in the MAC address table. Routing table finds a routing entry for the destination IP address. The destination network is directly connected. The next hop IP address is a unicast. The ARP process looks it up in the ARP table. So basically that is what happens. Okay, so we are going to finish here. I will continue with another video explaining the communication between this and this site and this site. Okay, that's it. I hope that you have liked this video. If you have some questions, please let me know. Send me an email or just let me know what is the question you have here in the comments in the video.